Hello and welcome to the lesson on relative error. What I want you guys to do is pause the video and using either a ruler or your own guessing skills, I'd like you to measure the four objects that you see on the screen. And then when you are done writing those measurements down, unpause the video and continue. Now that you have measured your height, the height of any door, of the room you're in, the width of the desk you're at, and the height of your chair, I want you to consider the question, what are some possible issues with the measurements you are getting? And what you should come up with is that there is always a chance that whatever measurement you took, no matter how careful you were, that the possibility of human error is there. So even if you use the ruler, you might have made a small reading error and you might have created a wrong measurement based on that. Now when this happens, to account for this human error, we calculate what is called relative error. And that term relative error means a number that compares how incorrect a quantity is from a number that's considered to be true. The way I want you to think of it is, how far off are you from the actual measurement? By what percent are you off? And that's what you're going to be able to calculate after this. Now to calculate relative error, it's 5 very simple steps, and in integrated algebra it's actually only 4, because you don't have to change anything to a percent. So to calculate relative error, you follow these steps. So consider example 1 as a type of problem you may see. A man goes to his doctor, and the doctor tells him he weighs 200 pounds. Okay? The man goes home and weighs himself on his own scale, and he measures 211 pounds. What is the relative error in his scale's measurement? And we are going to round this to the nearest thousandth instead of changing it to a percent. So I have to record the measured reading, and in this case the measured reading is what the man does at home, which is 211. Forgive me if my numbers are sloppy, I'm doing this with my mouse. There we go, 211. Now I record the accepted value, which is 200. That's what the doctor measured him as, so we are going to accept that as the true measurement. Alright, so we have the measured and the accepted value. Now all I do is I find the difference between the measured and the accepted values. You want this number to be positive. So always do the largest minus the smallest. Now let me erase this little mark. That's supposed to be a minus sign. That's my fault. There we go, that's better. And then you divide that difference by what the accepted value is. That's the important part. The accepted value is the actual value, which in this case is 200. So there's a 2, 0, 0. Wonderful handwriting. Okay, so you do this in one step in your calculator. Now if you enter it in the calculator, make sure you're putting parentheses around the 211 minus the 200. Now I'm going to do that in my calculator that I have in front of me. I don't have one on the screen, but what you end up with when you divide 211 minus 200 divided by 200, you end up with 0.055. And since it's a very easy number, I don't have to round it. This is my answer. That's my relative error. I'm off by 0.055 or 55 thousandths. So that's how much his scale is off. So that's a type of problem you may see. Let's consider another example. In geometric calculations such as finding area, volume, or surface area, error increases as the dimensions increase. So let's say John estimates the measure of a cube or the side of a cube to be 9 centimeters and the actual measure is 10 centimeters. I want you to see if you can do this problem on your own, and then what you're going to do is check back on the website, and I'm going to post the answer for this question as well as these 3 problems in the practice set. Be careful with example 2 because it's asking you for the relative error at the end here, what the relative error of the volume will be. Okay, so A is asking what's the relative error of his original measurement, B is asking for the relative error of the actual volume of the cube. Once you answer these 3 parts, try the practice set and I will post the solutions online. But if you need to, go back and copy these notes again, and that is all.